Nice to meet you guys. Good afternoon, maybe 12. I'm Boris from Metso. Metso is a equipment provider for mining and oil and gas, pulp and paper industries. So, big provider of equipment and services for that industries. And why not in an event like that talk about IIoT? And that's why that's the word that we say is IIoT, industrial IoT, and how it can improve our process too. So that's the aim of this presentation today. So first question is, do you know that the manufacturing industry is the one that most generate data in the world, right? So have you heard about that? So more than the government, more than the banking, more than the other ones is manufacturing. So, but what this industry is doing with the data? Is this amount of data really generating value to the business, to the industrial business? So that's what we will talk about today in this presentation. Okay, right. We have a lot of data. We have huge amount of data, but when we see in a typical process plant analysis, we see that, for example, 30% of the controls are still in manual. 20 to 40% of the controllers are oscillating. 30% of the valves have mechanical problems. The control system is kind of performing badly in some way, or in the looping, or in the control, or in an algorithm. And we also see potential to improve by 50% or more. So we see that there's a lot of opportunities, even with this amount of data, and we need to understand why, to chemical savings, to production increase, quality improvement, and reduce energy costs. So if we translate that opportunities, that potential to a graph, in a typical graph, then we will see something like this. Is a kind of way to distribute the opportunities. So the manual operation, for example, the process normally goes like this, very, very unstable because of the human behavior to control things. And then it's a big part of like that 30% that I said of the lost production, for example. The other big part of lost production is emergency shutdown. So you are not predicting the failures, and then it happens, and then you don't have the right pieces and parts, you don't have the right people there to change the parts, and then you stay for hours or sometimes days to repair. So this is the emergency shutdown. And also some part of the lost production is because of this disturbance condition. So because of some situation with some device that is not performing well, is like oscillating or is sticking, or the motor is not, the loop is not tuned, so you are in these disturbance conditions. And surely you have the planned shutdowns that are normal, that you need to really, after the wear, you need to stop the plant and go for the change. So, and then in the end, you have this small part that is good control. Then here you have process stabilization, you have everything tuned and stabilized, you have everything maximized. But if you see, there is a lot to improve here. And so we as Metso, we really believe, looking at that we can kind of divide that in three key levers to increase this situation, to be better on the operations improvement. So first of them is stabilize. So we really need to look at the tips and try to stabilize better the process. When you stabilize, gain a very big portion of improvement. And how to do it? A lot of software tools for that. You have full tools for that. And then you come from the situation like that to something like this. So it's easy. It's just tuning the loops, use the tools, and do the thing. Then you go to the optimization. Optimization, you have also softwares for that, and people. And the thing here is to softwares to learn for some period and try to check opportunities to find new set points. So the softwares can realize that, hey, if I increase a little bit the production, it will be okay for the equipment. It will be okay for the plant. It will not disturb the process. So why not just send another set point, for example, increase the feeding of some product or increase the speed of some motor. So there is room also for it. And the last one, and in my opinion is the most important one, is the maximize. What I said regarding the very big gaps because of emergency shutdowns, unplanned shutdowns, and so on. So if we can just eliminate it or reduce a lot by using online predictive maintenance softwares and people and engage that, we can reduce this situation with a very much like this, like just a planned shutdown, very efficient one, with the parts there, with the people allocated to do the service, and that's it. Because it's impossible, right, to run a plant without plant shutdowns. We need to stop to change the parts. So, and why it not happened in the past with these tools? Because the software tools are not new. We know that in the industry, software tools are very common. There is the controllers, there is the DCS, PLCs, historian systems, PIMS systems, and so on. So after some years working in this environment, with these customers, we realized that, for example, for the hardware and software tools, we saw that the focus is a lot in the control. So when the DCS or PLC providers put the systems to run the plants, they are taking care of to control. They are putting the efforts on the build the algorithms and control the plant. There's a lot of information, it's monitoring information, but no treatment of this information. So just send alarms, like, this is a limit, not good limit, so send an alarm. And then you have a flood of alarms and a lot of data. So this is also something that is not good. A small number of smart devices in the past. Now that more and more it's coming, right? When I say devices, I say inverters, motors, valves, positioners, instruments like pressure, temperature, flow, and so on. So the hardware and software were very much black boxes with heavy maintenance, data historians, so big servers, difficult updates, and so on. And the people, it's also part of this process of not collaborating too much to this process of improve the process. So few dedicated people really to do predictive maintenance job or to really analyze the data, really put effort on getting value from the data. Many device vendors to handle. So imagine few people like in a plant with 50 vendors trying to check what's happening with this valve, that is from this vendor, and this motor, and this inverter. So very difficult to have a kind of comprehensive way to with the devices. And no predictive maintenance mindset also. It's very much like corrective maintenance. And lack of local skills and training. So also things was part of this situation of not having a good performance from so many data. So what we propose with this situation, what Metso understands that it's a proposal for that. So we need really IoT condition monitoring tools in all levels. So when I say all levels, I say since from the field device, since from the equipment like valves, like motors, like instruments, to the controllers, to the stabilization through the loops, and also to the ERP level that you can connect to check what's happening with your inventory in an online way. So, but the key here is that you have the connection now with the vendor. So you need to use your vendor expertise in this process, because otherwise you stay with a lot of data again without getting the real value from the data. And then when we say IIoT and when we say this new approach, we are talking about transforming data to really information. And this is not about the common softwares that you have a software and you just put some statistics to try to get some value on that. When you are not counting on your vendor, for example, or you are not counting on the specialists in that equipment, you can do some statistics with the data, right? So what we recommend, what we propose here is really turn the data to information using the vendor know-how, and then prioritize the actions. And why I say prioritize? Because even if we come from the data and put some real valuable information, normally in a plant, the plants are very big, very a lot of equipment, a lot of devices. Then normally when you put the softwares to run, you get a list of 100 of things to do, right? And this is, and then people comes like, when I start, from where I start, so we need to have the information and we need to prioritize the information. And the way that we do that is by economic impact on the plant. So when you have the device list, we prioritize the actions by the economic impact. So I will give an example of turning turning data to information with a valve, for example. This is a valve, simple valve, that just controls the flow of the water. Water comes from here and goes outside, and then you have this device here to control, to open and close the valve. Very simple. Okay? Then this blue wave here is the command wave. I mean, I'm sending the command to the valve to open and to close. Open and close. It's a command from the PLC, right? Simple one. And the red one, this red one here is the response from the valve. So the valve, when I am sending the command to, hey, valve, open please. And then here, the valve is responding, okay, I'm opening, right? And then when I say to the valve, hey valve, close please. And then the valve doesn't close, and then close suddenly. So what's happening here? It's a stiction in the valve. So the valve there's a problem in the valve. So very simple information got from two kind of combined graphs that you just found a problem with the valve. So this is information. Data is different. You put statistics, and then you have some value on that, but you don't know what's really happening and where to go to solve that problem. Okay? So, and as I said, and how about do it for all of your devices in your plant? So really check with the vendor expertise and really do the prioritization here. Not only flood your guys, your maintenance guys with a lot of information that will not help. So then we can get all this data, we can do this analytics based on engineering, and then we prioritize by what we call payback loops, biggest payback actions. So when we are configuring the system, we can classificate each device in your economic impact in the plant. So then you really know where to go, where to start, and where to put your resources and efforts from your team. So, as I said, really take the information to action. So, and again, I insist in this action, and the action also together with the specialists, together with your vendors, your suppliers, because otherwise the information will be there in some software, in some room, in some server, with no action. So you really need the software part, the expertise, the algorithms, but you need the people engaged in the process so that really have the results. Okay, so I would say that to get started on that, what you don't need. So what we don't need here. We don't need 100% of smart instruments. That's not true. Normally when you say, let's do IoT in my plant, a lot of software, then, no, I will not go for it because in my plant is very old, or I need to do a very big investment to upgrade it, but it's not true. I would say why. I need a full sensor network infrastructure and gateways and parallel networks. Not true too. I need tons of IoT knowledge. No. I need common architecture, staffing, $1 million budget. Not true too. So what we really do need is some justification. We need a target, we need a goal. Like, okay, I have my plant here, and I check that 40% of my loops are in manual, are being controlled by human. So if I put everything in auto, I can see this is the gain that the benefit that I will have. So this is the justification for me, for the plant manager, for the company. I have some connectivity. So if you have a PLC, if you have a DCS, and you are collecting this data, process data, like as I showed, commands to equipment, responses, PV, COs, whatever abbreviation it is, you are already good. You already have data. If you have connection to the equipment that you are controlling, which is sometimes obvious. You need some support from IT, sure, just to connect some pieces, some servers and some software, but it's not a massive work. And you need to engage people. So really to the people to understand that this is the new mindset for the plant. So it's not just a side software. It's a program that everyone needs to be involved, having this prioritized actions to take the action. So this needs to be a mindset change. Ensure is that it's a cycle process. So every day the tools with the expertise of the vendors, the expertise of the plant teams, and the actions going in a cycle. We really have very good results by success cases in the industry, putting that program to run. Okay, so when we see the other industries, like not the manufacturing industries, we see that sometimes there are very big challenges in the data. We need to put still some sensors. You need to put a lot of smart devices to run because they don't have nothing. But in our case, it's different. So this is the good news for us. We already have the data. So the data is there. It's just put the right algorithms there, put the right prioritization, use the expert algorithms to know what's happening with the equipment, with the devices, and the teams to take the action. Okay, that's my presentation. Thank you very much.
Thank you.
Yeah.